I'd like to welcome everyone to the 30th Maura Whitehead Lecture. Throughout my attending these lectures, I've gotten to know Maura's husband, Dr. Peter Thorne, as well as had the privilege of meeting Maura's parents before they passed away. It is really great to be here with all of you today and to again share this wonderful annual event. I'm going to allow Dr. Thorne to share with you a few words in memory of Maura. So I would just like to begin by introducing our speaker today. Dr. Peter Thorne is the University of the University of Iowa's Distinguished Chair and Professor in the Department of Occupational and Environmental Health. He is the Director of the Interdisciplinary Human Technology Program. He runs a productive research laboratory engaging students in the studies of health effects of climate change, environmental risk factors for lung disease, the toxicity of forever chemicals, and novel methods for exposure assessment and modeling. Dr. Thorne is recognized for his discoveries on the exacerbation of asthma and other respiratory diseases associated with domestic and occupational exposures to bioaerosols. He has mentored over 76 master's students, PhD, and postdoctoral trainees, and authored over 300 journal articles. Dr. Thorne serves on the United States Environmental Protection Agency's Science Advisory Board and is the current chair of the National Academy of Sciences Committee on Technology. He is also a member of the Health Effects Institute Energy Research Board. He has received his master's degree in biomedical engineering and PhD in toxicology from the University of Wisconsin-Madison, and did his postdoctoral studies in toxicology at the University of Pittsburgh. That phase of his life brought us here to get to know us and Maura here at Children's. And so now, Dr. Thorne, thank you for joining us.
Thanks. Well, I want to thank Jen for that kind introduction. I'm really incredibly honored to be invited here to be the speaker this year. And just to, you said the word technology a couple times. It's actually toxicology, just to correct that. I don't want to take credit for something I don't do. Yeah, so I'm just going to first tell you that I have no conflicts of interest. And Jen and Noel and I talked about my giving this talk and thought it would be appropriate for me to say a few words about the person who this is named for. Moira was born in Appleton, Wisconsin, the same place where my mother was born, and graduated from Washington University in St. Louis with majors in Spanish and biology. And we met at the University of Wisconsin in 1980 in pathology lab. We were microscope partners, and which was probably one of the best things that happened to me in that point of my life. And Moira was an M1 and I was a PhD student. We were married in 1982, moved to Pittsburgh for residency, and for me, postdoctoral studies in 1984. And upon completing residency at Children's, Moira served as chief at Mercy Hospital's Pediatric Residency Program. And I was looking around the house and I found her name badge from when she was here at Children's Hospital. So that's the image there. From an early age, Moira was engaged with children, and especially children who had needs. She had a deep interest in the challenges faced by underserved and disadvantaged kids. This is a photo, and of course, black and white because it's pretty old, but this is a photo from her high school days, and she was working with kids who were children of migrant farm workers in Wisconsin, and here helping with the shoe. And then a picture. This is from really a residency or a medical school period of time. Moira was a very self-assured, purposeful, and highly contemplative person. She enjoyed quilting, knitting, hiking, reading literature in both English and Spanish, and was actually a state champion quilter, which she did while she was in lectures in medical school. And she died suddenly and unexpectedly on December 12th, 1987, 6 days after her 30th birthday. And our son Alec at that time was 5 months old. Cause of death was determined to be viral myocarditis. So to me, she'll forever be this vibrant, smart, and determined 30-year-old working to make the world a better place for children. And speaking of children, we have one on the line. So, and of course, most of us were devastated by her passing and stepped up to establish this lectureship in her honor. Doctors Leslie Sander and Barry Dashevsky were close friends of ours and helped develop the statement of purpose in the wee hours after her death. And the lectureship has continued to provide a forum for discussion of topics that relate to healthcare for disadvantaged, underserved, and disenfranchised children, and contemporary topics like social justice and environmental justice unfortunately haven't disappeared. So there's still a need for this topic to be presented to pediatricians and residents. And we were so fortunate to be able to get Robert Coles to be the first Whitehead lecturer at Children's Hospital of Pittsburgh. And he did so with grace and solicitude. And for those who aren't familiar with Dr. Coles, he's most known for his Pulitzer Prize winning books, Children of Crisis, which chronicle his work with kids as we attempted to integrate whites-only public schools in the South. And he particularly worked with Ruby Bridges, who was the first child to enter William Frantz Elementary School in New Orleans in 1960. He was a MacArthur awardee and also then received the Presidential Medal of Freedom from Bill Clinton in 1998. So he got us off to a terrific start. And I was very active in recruiting lecturers in the early days of the program. So I could always say, well, you know, you're going to be following Robert Coles, and then everybody would say yes. And so over the years, we've had a tremendous roster of people who've gone on to do great things, people who were working in the AIDS crisis early on, Jonathan Mann, people who were working in opioid problems, Rachel Levine, and many, many others working in injury prevention and control and delivery of healthcare to poor kids. And so I think it's fair to say that the lecturers have brought amazing individuals to children who have inspired us with their actions and intellect. And I have to note that this has been sustained over the years with unwavering support from Moira's parents, Howard and Mary, and our champions at Children's Hospital. And two people I want to call out, Dina Hofkosh, who was my main connection to the lecture for many years, and Carol Ashby at the foundation, who has made it all work over the years and actually is in really good shape. The baton has been seamlessly passed from Dina to Jen Wolford and Noel Spears, and I'm grateful to them for continuing the legacy of this. So now it's my turn, and I've chosen to talk to you today about one of the most critical issues of our time, and I believe one that will define a generation. To me, climate change, well, let me just say, climate change presents what many call an existential threat. I prefer to think of it as the grandest challenge of the 21st century. And so what I plan to do is briefly describe the challenge of climate change and climate justice and how we got to the point where we are. Then I want to lead us in thinking about what it means for children's health and their future. And I note that I've been teaching climate change for about 30 years, and I've learned a lot of things over that time from my students. So I want to share some of that, and then hopefully end with a more hopeful message on some recent progress and actions to address the climate crisis as it's unfolding. So just to get us started here, some just basic indisputable facts. And these are indisputable to nearly everybody who doesn't have a vested interest in the alternative. So carbon dioxide, methane, nitrous oxide are our three principal greenhouse gases. They trap heat and they warm the earth. This has been established solidly since 1896 when Svante Arrhenius did the calculations that showed how much this would warm the earth over time. The concentrations of these greenhouse gases have increased markedly. I note here that I was born at 314 parts per million carbon dioxide. We're now at 427. That's a huge increase in terms of the warming capacity. And the other greenhouse gases have gone along with that. Once these are released to the atmosphere, they stick around for a long time. Methane is maybe 20 years. Carbon dioxide is like 1,000 years. Others are intermediate in that area. And the major contributors to this have been energy and transportation sectors, and these have been increasing dramatically. Agriculture has also been contributing to the burden of greenhouse gases. And the result of this is global warming, sea level rise, ocean acidification, more extreme weather events that we've been seeing all over the world, and extinction of species both in the terrestrial and marine ecosystems. The other thing is we've exceeded the carrying capacity of the Earth by probably 2.5-fold, with this population going from, when I was born, 2.8 billion up to 8.06 billion now. It makes it harder for us to adapt and makes it a more urgent need to act quickly and decisively. And I'll show you some data on just how quickly we aren't moving. So this was a cartoon I developed to try and easily convey what's happening. You got the sun's radiation coming in as ultraviolet. It gets emitted as infrared, and these greenhouse gases in the atmosphere absorb that heat. This warms the earth. It's necessary to make the earth inhabitable, but when you have these in too high concentrations, you get too much, and you get the changes of expanding deserts and droughts, air pollution arising from secondary air pollutants like ozone and PM 2.5, also more biomass of allergens, so you have more allergy as a consequence of this, and moving allergens to new areas where they haven't been growing before in terms of allergenic plants, extreme weather events, hurricanes, tornadoes, derechos, extreme heat events, harmful algal blooms arising in waters that are stratified and way too warm, rising sea level, coastal inundation. And so these are really the drivers of health impacts that we're seeing. And one of the emerging concepts in environmental health has been that of the exposome, the notion that you accumulate exposures from prenatal period to the end of life, and that these are interactive in the domains of ecosystems, lifestyle, social factors, and physical chemical parameters. So the toxic exposures are in the physical chemical, but these are augmented by other aspects of our social environment or our physical inactivity or the foods that we eat and so forth. So when we think about the problems of climate change, we need to think of them in the context of our total exposome. And so the way this has been introduced as a concept, Jen noted that I serve on the Science Advisory Board for the EPA, and I'm the former chair of that board. This report came out, and we were active in vetting this, defining cumulative impacts as the totality of these exposures to both the chemical and the non-chemical stressors. You can't consider health without considering both domains, and this happens over a person's lifetime. So the impacts of in utero exposures and early life exposures manifest throughout your whole life, and so it's crucial to consider these. And so when we add this to a paradigm of the adverse outcome pathway, which has been used as really the model of toxicology for a long, long time. We think about all these exposures of air pollution, water pollution, drugs, diet, all this. And then when you compound that with the challenges of living in poverty, the stresses of that, maybe poor sleep because it's hot and you don't have air conditioning, and poor diet, then this feeds into this notion of the molecular initiating events that cause adverse health effects all the way up to the population level responses that we see. And then on top of that, now you add wildfire smoke or extreme heat, or actually both at the same time. And then you see that you have this notion of cumulative impacts really impacting the individual and the population as a whole. So this is the challenge for those of us who are doing environmental epidemiology, trying to understand the impact of all these things at once. It's not a study one thing at a time circumstance anymore. The other part of that is the population. So population really is a complicating factor. And at this point, there's not much we can do about it. We know where we're going to end up. We're going to end up at about 8.4 billion people, 10.4 billion people by about 2086. And the predictions of this are pretty good. There might be some prosperity or innovation that will maybe drive it a little higher, or of course on the downside, there's the bad stuff that can drive it lower, like war, famine, and pandemics. But pretty much we were at the inflection point of this where the crude birth rates are falling and the crude death rates are falling, and these will cross, and at 2086 we should have a stable population, and that will be 10.4 billion people. Now, the other part of this that we have to bear in mind is when we think about the impacts of climate change and these cumulative impacts, the very young and the older people have more significant are more significantly affected by this. And we see the median age from going from about 1965, and it was 20.3 years, because many countries had a population pyramid that was very flat, and we had a lot of young people. We're going to have an average median age of about 40.5 at that time. And so that means that the people above that age are in much greater numbers. And so they'll be more susceptible to the impacts of, say, extreme heat or wildfire smoke. The other thing that has been driving this, of course, is the increase in greenhouse gases. And here I use just carbon dioxide as the example of this. And, there have been a few events along the way that have slowed it down for a bit, but really it's been a steady march up to about very close to 40 gigatons of carbon dioxide. So that's really the greenhouse gas balance that we have in the atmosphere. And along with that, then looking at the Keeling curve showing the CO2 concentration in the atmosphere measured at Mauna Loa Observatory in Hawaii, you can see that we're up to 427 parts per million, and this just continues to climb. And we need to start to see this change. We need to see it level off, flatten the curve, and that has to happen very soon. So where's all this stuff coming from? Who's responsible is another way to ask that question. And when you look at the top 6 emitters, China, United States, EU 27 are up there, but the US really since 2005 or so has been flattening out and declining as we retire coal-fired power plants and as we improve the transportation sector. The European Union has been flat and then dropping also since about 2005. But China has modernized since 2007 by building a lot of coal-fired power plants. The U.S. has about 210. China has 1,142 coal-fired power plants. So in order to bend this curve, China will have to move away from that. And they're very rapidly building solar and wind and hydro power so that they can retire these coal-fired power plants. But now India has taken over as the most populous country of the world. So what will India do? Will India follow China's example to modernize, or will they take a different path? We hope they'll take a dramatically different path in order to not exhaust the greenhouse gas balance that we have left to stay below 2 degrees Celsius temperature rise. Now, fortunately, the oceans have taken up 91% of the energy that has been added to the system. And so when we talk about atmospheric warming, that's just a tiny little bit of this, and all the rest of this has been in the oceans. So when the oceans are no longer able to continue to take up this heat because of ocean warming, that will be a problem for us. And when we look at the temperature change since the reference period 1850 to 1900, you can see that we've gone up something like 1.36 degrees Celsius. So when you hear people talking about, oh, we have to keep the global warming down to 1.5 degrees Celsius or 2 degrees Celsius, which are the benchmarks being used by the Intergovernmental Panel on Climate Change, and at the Conference of Parties, we're already at close to 1.4. And so we really don't have much room left. And June 2024 was the 13th straight record hottest month globally in recorded history. And in the US, June was a full 3.4 degrees Fahrenheit above average, and the second warmest month in 130 years. So we continue to see this steady march forward of increasing global warming, largely unabated. So the Intergovernmental Panel on Climate Change put out the assessment report 6 a couple of years ago, and this figure is drawn from that. And they analyzed at that time the implemented policies in all the nations of the world, and said that if we continued with a business as usual, we'd be at about 3.2 degrees Celsius with wide confidence intervals there. But but really we needed to chart a path to get to net zero by end century, if at all possible. And that's where this 1.5 and 2 degrees C limit comes from. And I just looked at the data the other day. 2023, we're at 58 gigatons. So instead of marching down one of these, the blue or the green path, we continue to actually be going above the implemented policies pathway. So this really needs to change in order for us to get this under control. So then what does this all mean for public health? This is kind of where we are now, how we got here, where do we go from here, and what does it mean? So I talked about the drivers of this, the health impacts that we see associated with these, I think follow pretty obviously. Heat stress, dehydration are major problems. Many places are experiencing very deep heat events around the world, and certainly in the US. We're starting to see more problems with water, and we're starting to see wars and social strife arising because of limitations in water. Respiratory disease and allergy, cardiovascular disease associated with higher air pollutants, particularly secondary air pollutants. Harmful algal blooms making water supplies undrinkable and unusable for bathing. Severe injuries associated with these events and drowning. Vector-borne infectious diseases around the world and starting to affect the US, increases in malaria, Zika, chikungunya, dengue, and diarrheal diseases among child climate refugees are also a huge problem. And altogether, these produce a lot of potential for mental health problems and cumulative impacts when we add this to other factors like household exposures, poor diet, and the like. So that's really the statement of the problem. The challenge that we have then is to deal with the health impacts, adapt to the drivers, and try to, at the same time, mitigate the greenhouse gas emissions. So heat events are the major killer in the US associated with climate change. They have more impact than hurricanes and other events like that. And so we starting to see more of a problem with heat domes. And heat domes are a meteorological phenomenon. You can see here the jet stream being altered by this dome of heat. And what this does is it suppresses the air so that under the heat dome, it's like a lid on a pot. You're accumulating pollutants, and particularly it gives rise to secondary air pollutant formation. And so this is from last summer's extreme heat event. And then I just noted that earlier in June, there was a heat event in the eastern US that, and I picked this out of the New York Times about Pittsburgh with heat indices, and at the same time that people were without power. So usually what we find is that the extreme heat events affect disproportionately low socioeconomic status individuals who can't afford or don't have air conditioning. In Iowa, during last summer's heat event, I was doing some work in Cedar Rapids. They were closing the cooling shelters at 4:30 in the afternoon, sending people home, and the heat index was 118 degrees. So, I mean, we have to adapt to this and provide cooling centers for people who don't have another way to escape the heat. And if the power is going out, that's going to affect anybody who's, even if they do have air conditioning and can't run it. So these are issues that we have to be able to deal with. And when we have these heat domes, we're more likely to accumulate high levels of ozone and PM2.5, or fine particulate matter. And these are very important air pollutants for cardiovascular and respiratory disease. And they're secondary pollutants because they are generated from the action of the sun on nitrogen oxides and volatile organic compounds to yield the ozone. And so we expect to see very high ozone levels up until mid-century and beyond, even double the concentrations we've been used to at this time. And that has very serious consequences for children's environmental health. There have been studies showing that exposure to ozone and fine particulate impairs lung development among children. Really nice studies from the Southern California Children's Health Study. of course, the associations with asthma and asthma exacerbations, evidence of increased lung infections in young children, certainly poor sleep or sleep disordered breathing, and mental health issues arising as well. So I thought I would just talk about one study. There's a pretty rich literature in this area. I picked this one because it's a recent study, and I think was very well done, and it helps illustrate a point on cumulative impacts that I wanted to make. So this is a study of the ECHO Crew Consortium. Birth cohorts from 8 U.S. studies were combined with recruitment over the period of 87 to 2007. And the thing about these studies is they all had a 4-year and 11-year follow-up period. And it included over 5,000 kids in this meta-analysis, including Black, Hispanic, and white kids. And the major outcome that was assessed is caregiver report of a provider diagnosis of asthma. So this is a secondary report that's a very typical way to assess asthma in large studies of this sort. And the exposure assessment was conducted using daily estimates of fine particulate and nitrogen oxides from EPA data modeled to a 1-kilometer grid resolution, which is a technique that's widely used nowadays. And so because of the nature of the data, they used Cox proportional analysis, and they used as the measure of exposure, 1 interquartile range increase in fine particulate matter, and that comes to 3.4 micrograms per cubic meter. And that's a fairly small amount because the new standard is 9 microgram per cubic meter, but like with wildfire smoke, we'll see up to 200. And many countries of the world average 65 or 70 microgram per cubic meter. So this is not a particularly large benchmark to use. And so I'm just going to show a couple of figures from or tables from this particular study, but assessing asthma and PM2.5 at 4-year term and 8 years of age, and looking at the hazard ratio. If they used the exposure to fine particulate in the first year of life, this interquartile exposure, then the hazard ratio was 1.25. If they used the mean PM2.5 exposure from years 1 to 3, they had a very similar number. In this case, 1.3 was the hazard ratio. And just as a sensitivity analysis, they also did a logistic regression and came up with odds ratios that were also quite similar to this at age 4 and then at age 11. So I wanted to call out this particular number and then focus on that. So this is really looking at this 4-year follow-up period and looking at the mean exposure over years 1 to 3. And so if we pick that and we look at the stratifying this by sex and race and child opportunity index measured for education and health and environment, you can see that for instance, Black kids here, hazard ratio is 1.6 versus white kids with 1.17. And this is for the same increase in concentration of the exposure that they experience. And then when you look at child opportunity, which is a measure of social vulnerability, there's a number of these out there, deprivation index, social vulnerability, but it's a set of criteria used to judge the opportunities for children in a neighborhood in terms of education, health, and environment. And this is done normally at the census block level. And so you can see here that this has a very big impact on how much of an influence this interquartile range increase in asthma will have in that community. And so the bottom line with this is that for a Black child exposed to this much higher fine particulate, it confers a 60% higher risk of asthma. For a white kid, the same exposure is a 17% increase. And so this really, I think, helps illustrate this concept of cumulative impacts. There's something going on besides just the air pollution that is making these kids at greater risk of asthma challenges. And so if we look at fine particulate air pollution and air quality over the last 20 some years, we can see that in general, it's been improving. This is fine particulate matter, PM2.5. And you can see it going down, and the old standard was 12. And in February of this year, the EPA lowered the standard to 9 microgram per cubic meter, making it more stringent. And so, of course, this is responding to the research showing that this level of fine particulate continues to be dangerous to health. And I want to just shout out to Juan Celadon, who's here, that the American Thoracic Society did a great job of supporting and advocating for lowering this standard to be more protective, providing data and an amicus brief on the importance of making this standard more stringent. What I want to point out, though, is that when you look at this, this is the 80th percentile range. If you look at where we are with the national data, the 90th percentile, the 95th and the 98th are up here. So there's a lot of people still breathing bad air, and these people disproportionately are of people of color or people who are of low socioeconomic status. So it isn't distributed equitably among our population. And I did pull some numbers for Pittsburgh. Here's Allegheny County using the Liberty EPA monitor measurements over the last several years. COVID years were a little bit aberrant, so we have to acknowledge that. But you can see that here in Allegheny County, you're not meeting the standards, so you're a non-compliance county for fine particulate, but you're moving in the right direction. And so hopefully before too long, Allegheny County will be in compliance with this standard. Now, the challenge, of course, is that as we've been reducing these pollutants to a large degree because of less burning of coal, we've been retiring coal-fired power plants all over the country because they can't compete with wind, solar, and fracked natural gas. But at the same time that we're seeing the improvements from that, we're seeing more enormous wildfires. And so those are really hurting our progress. And so this is last summer, and this is taken from a paper we had in an online journal called The Conversation. And this shows the Air Now data from EPA. And of course, this includes Iowa and Western Pennsylvania on this particular day, showing that we were in the very unhealthy to hazardous range for air pollution. And this was coming across the border, largely from Canada. And of course, we can talk about closing coal-fired power plants or converting to e-vehicles to reduce our air pollution. It's a much tougher problem to deal with the extreme wildfires. And right now with climate change and the hotter temperatures and dry winds, we're seeing a lot more vapor pressure deficits in forests that have become overgrown. And so this is just a tremendous problem looking forward. And the health effects associated with this there's a lot of study going on right now trying to quantify these. It's difficult because there are multiple short-term events. We have distant transport, we have acute and chronic effects, and there's a lag time. But a lot of studies are being done, and what they show so far is that certainly young and elderly people are at greater risk, and those who have underlying disease. We know that wildfire smoke is more toxic than comparable levels of urban air pollution. Children aged 0 to 9, we're seeing asthma exacerbations, acute bronchitis, respiratory infections, and curiously atopic dermatitis associated with this. Congestive heart failure and ischemic heart disease in seniors, and people with diabetes are at risk as well. And so the evidence from like a 10 microgram per cubic meter increase in PM 2.5, we're seeing something like 8% increase in asthma and COPD. And 10 microgram per cubic meter has to be in the context of a 200 to 400 microgram per cubic meter increase during wildfires. So very significant risk to health. And the problem, one of the problems with this is that these events are unregulated under the exceptional events rule from EPA, and how would you regulate them anyway? And so this is really causing an erosion of the gains that we've made in terms of controlling regional and national air pollution. So I'll just show one plot from a terrific paper that was published in Nature last year by Burke et al. And if you look at the western states, the Northwest, the West, the Northern Rockies, the levels of fine particulate were decreasing until about 2016. And then you see these big spikes with wildfires and you see increases happening. And even in some places more remote from there, we see this at least leveling out. So the progress we've been making has really been slowed tremendously by the wildfire events that are happening. So in terms of public health interventions, what can we do? Certainly monitoring air now, which is EPA's app, can be very helpful, can tell you what the conditions are at any time. This isn't just for wildfires, but it's for any such events. Patient education on these hazards. For those who can afford it, having a home HEPA filter or high efficiency ventilation filters is good, but that's expensive and out of reach for many poor families. Cooling shelters, public libraries, community buildings are essential, and they need to be open when the events are happening. They can't close at 4:30. Advising people to wear a properly fitted mask when outdoors. I think people are now pretty accustomed to that. And increased bronchodilator use and other medications for asthmatic children in these events is recommended. So what about mental health? So this is something I want to make sure and talk about, because I hear from many people, particularly in Europe, more so than the US, that mental health problems associated with climate change are arising. It's often called eco-anxiety or climate anxiety. And so it arises from several different pathways. First of all, there's ample evidence of increased interpersonal violence, war and strife, and coup d'etat, and there's a number of police reports associated with increasing evening temperature anomalies. And so when you look at various jurisdictions, this is 26,000 data points in this particular plot looking at violent crime as a function of temperature anomaly. So we see more interpersonal violence, and that's something that has to be dealt with. The other thing is, over time, we're seeing a lot more billion-dollar disasters here in the U.S. NOAA uses billion-dollar disaster as a benchmark for severity of a disaster. And you can see over time from 1980 to the present, we're seeing more of these happen each year. That's the bars. And then the red line that you can see here is the losses in CPI adjusted dollars, with some years where there's major hurricanes like Katrina and Harvey and Irma causing very, very substantial losses. And so underlying all this is the people who lost their jobs, lost their homes, lost their loved ones, were displaced, and the mental stress, psychological stress that imposes upon people and children, of course, as well. And so I was looking into this really because of this talk, wanting to understand more about the impacts on young children. There's a lot less known about that, and this movie Inside Out 2, which I haven't seen yet, just came out, and notably has a character named Anxiety that is very important in Riley's life. And so I think that I pulled this quote from Dr. Ayanna Elizabeth Jackson, who has a book coming out very soon. This was from the New York Times. Some people are motivated by bad news. Some people need that jolt, and that's what gets them going. Some people are overwhelmed by that as well. So we worry about the people who are overwhelmed by that, and we want to figure out, how do we channel that energy for good to get them going, inspired to become active, rather than just being overwhelmed and unable to do anything. And then Dr. Lisa D'Amorza, a psychologist who was a consultant for the Inside Out 2 movie, and she was quoted on NPR saying, "Anxiety has value if our reactions are proportional to the threat," which got me thinking, okay, what is proportionality in the context of a global problem like climate change that seems to many to be existential? And so we have to kind of put that in balance as well, and impart the notion that we can solve the problem and empower young people to do so. And so in that realm, I teach this course. I started this course 7 years ago because we did not have a course on climate change at the University of Iowa, one devoted to that topic. And I wanted purposely to make it an undergraduate course and to make it open to everyone. So it's a general education course that everybody can take. And we fill the largest lecture hall and have a wait list every year for it. So I think it's making a difference. And so I don't have time to go into the details on this, but it's 37 hours of instruction on climate change, covering everything from the history all the way to how we can solve the problem and what individuals can do and how to talk to climate deniers, and giving students the tools and the education to empower them to be able to take action. And I've learned from them a lot of things. First of all students now accept that anthropogenic climate change is happening. When I started teaching about climate change 30 years ago, this was not the case. I got a lot of pushback. I don't get any pushback anymore from this generation. Also, all students feel that the adults are not taking meaningful action to mitigate climate change. They see it as a problem they're inheriting from us. And I like this figure because it kind of conveys their viewpoint of what's going on. A bunch of people of my generation standing around talking and not taking action while the sea levels rise and the climate worsens. So I'd say I also teach this in Denmark every year. I teach climate change twice a year in Denmark, virtually usually. And so I see a lot more climate anxiety in the Danish students and a lot more thinking about the future than I do in students in Iowa. But many students have eco-anxiety and believe that they will be displaced by climate change sometime in their life. And of course, in Denmark, I see that more than in Iowa. They question whether it's wise to have children and what kind of a world they would face in their future. They feel that in Iowa, their location, and they're mostly affluent kids, so they have privilege that will make them less impacted, yet they recognize that many don't have that kind of privilege, and so it's important to take action. And many of them want to take action to avert the climate crisis, but they really don't know where to start. They don't know how to do it. And so increasingly, we're having student groups that have arisen from my class. There's also a medical student group. There's a engineers for sustainability, a number of student groups that are really taking this up in a very meaningful way. And we got some money from Burroughs Wellcome Fund to develop an entrepreneurial challenge for students to develop projects that's really taken off and highly successful. So that's the perspectives from my teaching. I just want to close with what's happening here and see where we are. Oh, I'm behind. So I'll just say that we've made a lot of improvements in air pollution with PM 2.5 sulfur dioxide going down. And fortunately, these improvements have helped everybody. So that's really important to see. The Inflation Reduction Act and the Infrastructure and Jobs Act, sometimes called the Bipartisan Infrastructure Act, have put out enormous amounts of money in the sectors of improving weatherization and homes for poor families, reducing air pollution with an eye towards environmental justice, changes in agriculture, electric vehicles, shipping, buses, transit, and improving our electrical grid so that we can modernize much better. The transition to e-vehicles is moving very quickly. And this is important because they contribute about a quarter of our emissions. And so by 2032, we should be reducing automobile emissions by half just by electrifying. And there's a major emphasis on electric buses because diesel buses idling at schools are a major contributor to child health. And a lot of kids spend a lot of time on diesel buses, particularly in rural areas. And so here's what the world is doing on e-vehicles. Everybody's making their way up by 2035. Norway, I was in Norway last year, and they're at 80% right now. So it really can be done, moving to e-vehicles rapidly. And it's had great, if you go to Oslo these days, it's quiet, it's clean, it's beautiful. So just to finish here, can we end the climate crisis? Not in the near term at all, but we have to try. We'll be seeing a lot of changes on health and well-being of adults and children, and we really need to take dramatic action, much more than we've done so far. It's not a science problem, it's a political problem. The science is there, and we just have to accelerate our move away from greenhouse gas emissions and really put a lot of effort into adaptation as well, because it is upon us. And it's important to equip young adults with the tools, because it's the problem that they're going to deal with, since my generation seems to have failed them. There's some increasing literature, videos, things out there for young children to help them understand the climate crisis and to give them not doomsday scenarios, but really a notion of how they can behave in order to help the climate crisis. And this one in the New York Times was particularly great. And I wanted to just end with that, and thank you for your attention.